Hello, this is a recording of the talk that I gave at the 2021 Blockly Developer Summit talking about the nominal connection checker that I've been working on. It is intended for people that weren't able to attend the session where I gave the talk, as well as so that I can refactor some of the answers to questions that I gave. So a connection checker allows you to define which blocks can connect to which other blocks. For example, this dog block can connect to this mammal block, but it cannot connect to bat. And because dog can connect to mammal, this means that this is actually an example of a subtyping system where dog is a subtype of mammal. Now, subtyping systems are possible to create with the built-in connection checker, but they're a little bit repetitive and as such slightly error-prone. So to try to combat that, this plugin implements something called the type hierarchy, which is basically a centralized place for you to define your subtyping information. Now, that's pretty cool, but it's not any more powerful than the built-in connection checker. That is where generics come in. So generics are blocks that change their behavior based on the blocks they're connected to. For example, when I connect this identity block to this dog block, now it can only connect to dog or mammal and not to bat. And the interesting thing about this is that this is done only using connection checks. It doesn't include any complicated mutators or extensions. All you have to do is assign your generic checks to the different connections. So that's pretty rad, but the real question is, how fragile is this system? And I can tell you that it is not fragile at all. For example, this dog block here means that this select random connection can only connect to dog or mammal and not to bat. This works because generics are evaluated recursively until all of the connections have been assessed and searched for explicits, which means that it is impossible for your users to create a badly typed set of blocks. Similarly, this dog block here means that this bat block cannot connect to any of these connections. Now, there are other things that I would love to talk about with regard to generics, but I know that what people are really interested in are parameterized types. So parameterized types are types that rely on other types. For example, lists, dictionaries, and sets are all examples of parameterized types. And for those interested, this plugin does support 3 parameter variances. It supports covariant, contravariant, and invariant, and they are respected. This means that I can take a getter list of dog and connect it to a getter list of mammal, but I cannot connect them the other way around. Now, there are other things that I would love to talk about with regard to this plugin and other behaviors that it does, but I wanted to keep this talk brief and so that I can answer questions. In the future, this plugin will also support bounded generic types and generic parameterized types. So that'll allow you to get more power than just the things that I've shown here as well. But to summarize, what do I think that this plugin is useful for? So first of all, I think that it is useful for modeling languages with nominally typed systems. That's text-based languages like C++, Java, Rust, etc. Hopefully this will just be like the way to model those languages in the future, or that's the idea. Anyway, we'll see if it actually happens. But the other thing that I think this is useful for is eliminating static semantic errors. So static semantic errors are any errors that would be thrown by a compiler. And I think that it's important to eliminate those because a lot of the people using block-based programming are beginners. They're kids or they're just generally non-developers. And I think that dealing with those errors is really frustrating for them. So as much as possible, I think that it's our responsibility as language designers to try to prevent those errors from even happening in the first place. So I hope that this plugin represents a way that we can get rid of static type checking errors altogether in the same way that block-based programming in general has allowed us to eliminate syntax errors. Now, if you want more information about this project, you can check out the design document here. It lays out all the things that are going to happen in the future in a lot more detail. If you have any comments or questions, you can also email me directly at this address. I love receiving emails, so I would love to answer questions. or you can ask questions in the comments below. And then the other thing is that this is actually a public demo on my website, so I'll have a link to that in the description, and you can come and define your own blocks and your own type hierarchy and really play with all of the functionality that this currently supports. Now I'd like to go over some of the questions that I received at the summit, but again, if you have other questions that aren't covered, feel free to leave them in the comments. So the first question I got was whether this plugin would support downcasting. And my understanding of how downcasting works semantically is that it's basically saying, I would like to try to convert this type to another type. I know that you can't really check this statically, but I would like to get a runtime type error if it doesn't work. So that is sort of possible to create with the current version of this plugin. For example, if you imagine that this identity block instead was a downcast block where it might have a drop down where you could select which type you would like to downcast to, then it would have a generic input over here, and the output would be whatever type is selected in the drop down. You could create that right now using some of the API functions that I didn't mention earlier or didn't have time to talk about. But the thing is that I think that's a little, it's not as restrictive as you could make it with some of the future features that will be added to this plugin. So what you don't really want to support is people trying to downcast a mammal to a chair, because obviously that's not going to work. Why would you even allow users to try and do it? So in the future, you will be able to have a bounded generic types, so you could say that this generic must be a super type of whatever is supported in the dropdown. So for example, you can downcast a mammal to a cat, or attempt to anyway, but you cannot attempt to downcast a mammal to a chair. So it's sort of possible to support downcasting already, but in the future it will be a lot easier to. The other thing related to downcasting is I would like this plugin to be able to support type switches, but I don't know if that's going to be possible without at least some additional features on top of the basic plugin. So I imagine a type switch would look sort of like an if block, where you have inputs that accept the type that you would want to check against, and then a statement input where the variable or whatever has been cast to that type. So that function where the statement input changes the type of the variable is not something that this plugin would handle, but I'm hoping that with some additional extensions or mutators that would be able to be supported, because I think that in general type switches are sort of easier to understand than downcasting. I don't have any evidence to support that, but that's just my opinion. So I'd like to be able to support that as well. Then the other question I got was related to list blocks, like the built-in list blocks, and how easy it is to upgrade to those, and whether this plugin will support creating blocks like that. So this plugin will definitely support creating things like the list blocks, but this version does not support them yet. However, in my dev workspace, I am working on implementing that right now. So you can see that I have a list of bat here, and the block definition for that is right over here. So this input is a generic T, and then the output is a list of T. So when I connect these together, this output is essentially a list of bats. And as you can see, this relies on the generic parameters, which, as I said, aren't yet supported in this demo version, but I'm working on building that out right now. There are a lot of issues related to that and a lot of edge cases, so that means I need to do a lot of testing, manual testing, automated testing, but it's getting really close to being done, so I'm super excited about that. Then the other question related to lists was, will I need to redefine the built-in list block to support that? And the answer is yes, because the information about working generically is included in the type check, which means that you will need to redefine the block definition. So I said at the summit that you may be able to reuse the mutator, but looking into it, I don't think that will be possible, because when the mutator goes to add more inputs, for example, if we imagine the select random block is instead of a list block, when it goes to add new inputs, it sets the check of those inputs. But for this to work properly, you need the check to be a generic, which is not how the built-in mutator that comes packaged with Blockly works. So you would need to redefine the block and redefine the inputs. The other problem with this is upgrading. So basically, when you move to this system, you are making your type checking system more strict than Blockly's built-in type checking system. So, for example, if you had a list that had a chair and a dog and a number connected to that, and you tried to load it up in this plugin, deserialize the XML for those blocks, it would break your save. This connection checker would not allow those blocks to connect, and it would basically blow up your deserialization. So that is a problem with core Blockly, where it doesn't currently have any versioning support, so it's really hard to make the type checking system more strict than whatever the original type checking system you released with was. But hopefully in the future, Blockly will have better versioning support, so that isn't as much of a problem. If you really want to upgrade to this anyway, you can build your own versioning system. I know that App Inventor has a versioning system that they maintain, and I believe that Makecood has one as well, to make sure that changes to their languages are backwards compatible to the earliest version of saved XML that they have. But that does require more work on your part, because you have to build out that system, test it, and maintain it. So I believe that that's all of the questions that I got at the summit. Again, if you have other questions, you can email me or leave them in the comments below. I have had a lot of fun working on this plugin, and I have had a lot of fun talking about it and talking to other people at the summit as well. So thank you for listening to my talk. I really appreciate your time.